What is logarithm? In 9th-10th grade or in class 11, when we first got acquainted with logarithms, it is like mystery surrounded us. Because its appearance, operations and features are different from others. But logarithm possesses a mysterious relationship with your brain. In this short video, we are now going to discuss this mystery. Let me ask you a question. For which exponent of 2, its value is 8? Very good. 3. That is 2 to the power 3 equals 8. Again, what exponent of 2 needed to get 16? Very good. 4. You guessed the correct answer again. That is 2 to the power 4 equals 16. Now, if exponent of 2 is 3.7, how much we get from it? It's difficult question for you, isn't? It's a difficult question for me too. In fact, it takes a lot of time and patience to determine this value. However, it is easier to guess. Considering previous two instances, we can understand that value of 2 to the power 3.7 is greater than 8 and less than 16. Thus, the value of 2 to the power 3.7 lies between 8 and 16. Using a scientific calculator, we get 2 to the power 3.7 equals 12.996000383 ... It is an irrational number. Now think differently. An index of 3 applied on 2 gives 8. And an index 4 applied on 2 gives 16. So, what should we apply on 2 to get a value 14? I don't think you have the answer right now. You cannot evaluate each and every exponential term that appeared in your calculation while working with large mathematical expression. Therefore, you need a shortcut. And logarithm brings you the shortcut. The required index in our problem can easily be expressed as logarithm of 14 to base 2. That is, the mathematical symbol for the index or power that applied on 2 to get 14 is log 14 to base 2. Therefore, 2 to the power logarithm of 14 to base 2 equals 14. Thus, we can say what index of b needed to get m. The answer would be logarithm of m to base b. Or b to the power logarithm of m to base b is equal to m. For which power of x it is n? The answer would be logarithm of n to base x. That is, x to the power logarithm of n to base x is equal to n. What we understand from these? Logarithm is an exponent or power. Logarithm is used in a situation when the base and the value are known, but still exponent remaining unknown. What index can be applied to a base to get a known number? This required index or power is the logarithm. This is why in mathematics, expressions involving index or exponent often includes terms in logarithm. In science and technology, 3 types of logarithms are widely used: common logarithm, natural logarithm, and binary logarithm. Common logarithm. When the base of the logarithm is 10, it is called the common logarithm or standard logarithm. The unit of decibel or bell used to determine the intensity of sound is in fact a common logarithm number. The pH number used in determining acid-alkali levels of a solution is actually a dimensionless number. Common logarithm of the number of ions in a solution is the pH number. Also, Richter scale used in measuring intensity of an earthquake is a common logarithmic number. Common logarithm directly related to our perception. Because our brain assesses physical quantities such as intensity of sound, brightness, smell, etc. in common logarithmic order, not in linear scale. In linear scale, a 10 added to another 10 doubled its value. But in logarithmic scale, if you want to double the value of 10, you must add another 90 to it. Because log 10 equals 1. And log 100 equals 2. What do we mean by this? That means, suppose you are smelling 10 roses. Your brain calculating the amount of scent in it. And if you want to double its aroma, you must need 100 similar roses. Also, if you have 10 candles in your room, and your brain assessing the brightness from them, and you want to double the sense of brightness in the room. To do so, you need 100 similar candles there. Had your brain worked according to a linear scale, then 20 roses or 20 candles could double your perceptions. Natural logarithm. If exponential a is taken as the base of a logarithm, then it is called a natural logarithm. It is renamed as logarithm Neperian in honor of the inventor of logarithm, John Napier, and denoted as Ln. It is used in crucial calculations of integration and differentiation in calculus. Binary logarithm. The logarithm with base 2 is the binary logarithm. Binary logarithms are very important in the calculations of computers or digital electronics. Hope this tutorial to be helpful in building clear concept in you. If you like the video, encourage us with a like.